Good afternoon. So yesterday I spoke about how to prioritize between different interventions and different cause areas. And today I'm going to dive into one of those cause areas specifically, the area of the long-run future. And so hopefully by the end of this talk, I will have presented some arguments for why I think the long-run future is an important area to work on. And hopefully by the end of it, you may think that too. So this is in Indonesia. This is the site of a supervolcano that erupted 700,000 years ago. It ejected 2,500 cubic kilometers of magma into the atmosphere, plunging the Earth into initially darkness and then a half a decade long volcanic winter. This had dramatic effects on life and animals throughout the globe. And there's still debate among the archaeology academia as to quite how extensively this affected humans. But there's some decent evidence that suggests that the human species at the time suffered tremendously, with perhaps as few as 3,000 survivors worldwide. Now, if this eruption had been worse, there's a very real possibility that none of us would be here today. So a supervolcano is one example of an existential risk, something that could permanently destroy humanity's potential to achieve a bright and prosperous future. And at the Future of Humanity Institute, we think a lot about both the ethical and scientific dimensions of these existential risks. So I want to begin by talking about the ethical dimensions. So a philosopher at Oxford, Derek Parfit, brings us a wonderful thought experiment. He asks us to consider three scenarios. Scenario one, in which you have world peace, everyone lives in harmony, things are great. Scenario two, we have a horrible nuclear war, and 99% of the population on Earth is killed. And in scenario three, we also have a horrible nuclear war, but 100% of humanity is destroyed. Now, obviously, scenario one is the best scenario. Scenario two is second best, and scenario three. But the more interesting question is, what is the biggest difference between these scenarios? Is there a bigger difference between 1 and 2? Or between 2 and 3? Now, a lot of people think the biggest difference is between scenario 1 and scenario 2. After all, if we consider the number of people living on Earth, then the difference between scenario 1 and 2 is about 7 billion people dying. Whereas the difference between scenario 2 and scenario 3 is only about 70 million people dying. So if all we care about is who's currently living, then the biggest difference is between scenarios 1 and 2. But what do we lose with scenario 3? What does this scenario look like? We are not only lose the people currently alive on Earth, but we also lose the possibility for future generations. We lose the possibility of a flourishing civilization and its continued accomplishments that our species has accumulated over the past 200,000 years. And that's why I think, personally, that the difference between scenario 2 and scenario 3 is vastly larger if we consider the possibilities of the future. So how valuable is our future? The potential value is actually pretty staggeringly high. Eventually, the sun will burn bright and turn into a red giant in about 1.1 billion years. The oceans will evaporate, and complex biological life on Earth will likely come to an end if we remain in our current orbit. But before that, if we assume that the planet can sustain about 1 billion people at any given time, and that if we assume each person lives for about 100 years or so, then what we find is that the Earth could support another 10,000 trillion lives, or 10 to the 16 lives. So this is a pretty huge amount of people. And so if you buy this argument, and you buy that we should be using expected value calculations for determining how much good we can do here, then even just reducing this chance by 1/1,000,000th of a percentage point is like saving tens of millions of lives in expectation. Now, there's plenty of good counters to this argument, and we can go into that on the panel later. But this sort of gives you a bit of a sense of why it could be that working to reduce existential risk and working to improve the long-run future could be a very valuable thing to work on. So I want to take this actually a step further. And now, I want to warn you in advance that the next slide is very speculative. This is more just to give you a sense of what the possibilities could be to come down the line. This is the argument around astronomical stakes. So more speculative, we can ask, what is the upper limit of happy lives that could exist if humanity were able to spread across the accessible universe? So if we assume that we are able to somehow run our minds on computers rather than this sort of fragile wetware that we were born with, and we also assume that we're able to spread across the accessible universe and use the available resources to create additional computers to run minds on, then what you find, Professor Bostrom estimates that the universe could end up supporting 10 to the 58 sort of mind lives if we were to use all of these resources. So this is not to say this is what's going to happen, or even that it's likely. This is just to give sort of an upper limit of what we might be able to achieve if we were to head in this sort of direction. Now, 10 to the power of 58 is an enormous number. It's one that I personally can't really get my head around. So Nick Bostrom represents us this, he gives us this analogy that if we represent all of the happiness of one entire life with a single teardrop of joy, then this happiness of these 10 to the 56 souls could fill and refill all of the Earth's oceans every second and keep doing so for 100 billion millennia. So this is a lot of lives that we're talking about here. And yet all of this could be curtailed if humanity were to go extinct over the coming couple centuries. So what could cause this to happen? So these are some of these examples of natural risks that could cause human extinction. Asteroid impacts, supervolcanoes, natural pandemics, gamma ray bursts. However, I think there's a sort of single argument that, for me, suggests that these are unlikely to cause humanity to go extinct over the coming century and probably don't deserve as much of our attention. And this is quite simply that, historically, humans have survived for over 200,000 years with naturally occurring diseases and asteroid impacts. And so, given that we've survived for these 200,000 years, it seems unlikely that one of these things is going to wipe us out over the next 100 years or so. We can use a simple method like Laplace's law of succession, a statistical technique to estimate what the chances are that we will go extinct over the coming century or so. And so if you use this 200,000 years as your time frame, then you get less than a 1 in 100,000 chance that we go extinct. Now you could argue that perhaps 200,000 years isn't the right time frame. Perhaps we should only be counting the 10,000 years since agriculture. You could say that this is complicated by a number of factors, such as modern travel. But even once you start to add these extra complications to your model, you still find it's pretty unlikely that humanity will go extinct because of one of these natural causes over the next century or so. So then we come on to other types of risks that you can't explain away with these by looking at the historical trends. And we call these anthropogenic risks. These are human-induced risks, things that have been brought about by human activity. So we have nuclear war, climate change and geoengineering, engineered diseases and bioweapons, advanced nanotech, machine superintelligence. Now, some of these are already getting a lot of attention. Things like nuclear war and climate change, you've got thousands, probably tens of thousands of people working to avert each of these risks and avoid the potential for existential risks from these sorts of areas. So then you've got these more emerging technological risks, which are the ones that personally I spend more time worrying about. And so for the duration of this talk, I want to dive into two of these in particular, engineered diseases and bioweapons and machine superintelligence. I'm going to talk less about advanced nanotech simply because it's much further off, whereas I see the potential for these other two emerging in the next few decades, potentially. So let's move on to discuss the risks of engineered diseases. Now, this is some numbers associated with deaths from wars throughout human history. And you can get a sense here, these all adding up to about 186 million people. Now, by comparison, we've got two of the major diseases just in the past century, killing far more than you've got sort of from most of the wars, even in history. And in particular, look at this number for smallpox. Just between 1900 and 2000, bearing in mind this was wiped out over the past century, you've got a number far, far bigger than that coming from wars. And so you might be thinking, what does this have to do with engineered diseases? Like, it's not as though scientists are going to go and sort of bring these things back to life so that we could have this many people die from them again. And yet, actually, that's exactly what we now have the potential to do. In 2005, scientists resurrected the 1918 flu virus from scratch using DNA synthesis techniques. Now, what these are is, over the past few decades, we've been developing the ability to read genes very well and read them quite quickly. And then over the past decade or two, we've started developing the ability to write genes and to synthesize DNA sequence by sequence to create novel strands. Now, this has some incredible upsides. It's hypothesized you could cure previously incurable diseases. You could create new genetically modified foods that could dramatically increase crop yields. There's a whole host of global problems that these things could help to tackle. And yet, there are also these huge potential downsides. We could be creating new diseases or even bringing old ones back to life. So, what's especially challenging here is that diseases which have been eradicated historically, most people no longer have immunity to these diseases because they haven't been around for a while. And so for something like smallpox, it's very fortunate that it's sort of difficult to make this, in part because it's actually hard to get your hands on the genomes for a pandemic like smallpox, except that it's not. These things are easily available on the internet. This took me just a few minutes of Googling to find. And so we can synthesize these sorts of DNA strands, and you can do this just by sending them off to companies around the world that will do this for you. The real challenge is actually turning this into something that could then spread in human populations, and that's actually, these days, really quite a challenge. Your average PhD student with several years' experience in a top laboratory probably wouldn't be able to do it. But this is something that's becoming easier and easier. Now, I'm not sure whether it's a good or a bad thing that I can put up here the DNA sequence for smallpox, an eradicated disease. This information could be a good thing that helps us design countermeasures against diseases like these and others. But it could also be a really bad thing. This could allow people to create these diseases and spread them around the world. And how we handle questions like this is really still an ongoing debate, and one that urgently needs to be figured out. And so I'd encourage people to dive into questions like this and help contribute to this, because this is still an ongoing question, is how you deal with these sorts of information hazards, as we call them. Now, I want to dive in a bit more into some data here and show you a graph. So on this side, we've got case fatality ratios. This is, if you get a disease, what's your probability of dying, essentially? And this is the reproduction number. If you get a disease, how many people on average will you pass it on to? Now, we can take a number of different diseases, well-known diseases. You've got sort of Ebola and AIDS here on the left, and you've got measles and whooping cough here on the right. And what you'll notice is that these diseases follow a natural pattern, which is that they all stay in this sort of, below this sort of region of the graph. And this is because for a disease to survive, it needs for its host to survive, so that it can then be passed on. And so what you find is that diseases don't spread fast and kill people fast, because then the disease would wipe itself out. Now, this doesn't actually apply for things like Ebola, where the disease is spread on through corpses as opposed to through living entities. But this does apply for most diseases. And so this actually gives us a sort of a nice, natural, evolved effect, which means that things can't get too bad. You can't get things that are up in this side unless you start engineering them. And so this is an example of an experiment that's been done in mice recently, which was which allowed us to move a specific disease up to getting 100% case fatality ratio in mice, sort of entering into this previously uncharted territory on this graph. And so the real worry is that we'll be able to design diseases that move us into this sort of territory, which could spread around the world rapidly and kill people fast. And even worse, if they were to have a long incubation time, like HIV/AIDS, they could spread across the globe before people even realized that this was a problem. So this is the sort of nightmare scenario that keeps me up at night. And this is the sort of scenario that I think we need to be taking steps to avoid. Now, how would a disease like this get out? There's really two types of problem that I think we can break this down into. The first is natural accidents, and the second is intentional malice. So let's discuss these one in turn. So first, rates of accidents. These sorts of experiments that I've been talking about, gain-of-function research, where you give diseases new abilities or you allow them to spread in novel ways that they haven't been able to do before, they have to be done in biosafety level 3 or 3+ facilities. And yet, accidents still happen at a worrying rate, roughly 2 per 1,000 laboratory years. This means that a research program running for a decade at 10 different laboratories has nearly a 20% risk of resulting in at least one laboratory-acquired infection over the course of that decade. And so, for example, the chance of this sort of event leading to an outbreak has been estimated to be at least 10% for some recent experiments that have been going across the world for flu. Now, you might think, well, these probabilities are relatively low. Surely this doesn't actually happen. But in fact, it does. An outbreak in 1977 of a flu pandemic, which emerged from the China-Russia border, spread rapidly across the world, killing thousands of people. Now, what was particularly interesting and novel about this is that it was the exact same strain as the 1955 virus. It hadn't evolved a bit. And so if this had been alive in the human population or in an animal population, it would have evolved and you would have been able to see differences in that DNA sequence. And yet, it was the exact same strain, suggesting that it had been kept frozen in a laboratory for those 22 years and then accidentally leaked. And when you looked into it, there was in fact a Russian lab just north of the border working on this exact same strain of flu, suggesting that it's pretty likely that it leaked out of this Russian lab and then spread across the world. There are similar arguments like this about British foot and mouth disease, which there's some sort of pretty compelling chain of reasoning that it leaked out from a drain in a laboratory in South England, spreading across Britain. And this was one of the sort of major events of my childhood. You couldn't eat you couldn't eat beef because of the disease getting into the beef there. And again, this was an example of a leak that was, you can't say for sure, but all of the evidence points that it was leaked straight out of a government lab. So this is accidents. But what about bioweapons? This is potentially even worse. If you were to have organizations or countries, administrations that wanted to design weapons that could be particularly lethal, especially if you were doing sort of more theoretical research to see what the extent of capabilities were, things you would never actually use in warfare because they would just be too bad. Now, this sounds like something that you'd think, like, why would you experiment on seeing how lethal you can make a disease? And yet, this is actually something that does happen a fair bit. The recent H1N1 cases that you may have heard of, using ferrets to transform a disease so that it was transmissible through the air when it had previously not been, is a great example of sort of taking a previous disease, making it much more transmissible, which would be pushing up its reproduction number, shifting it right on the graph that I showed you earlier. And so this is the sorts of experiments that people are actually doing, which could be good for humanity if it turns out that these things allow us to create defenses against these sorts of diseases. But they could also be incredibly bad. And my money is actually on them being pretty bad, at least in the near term. So what sorts of countermeasures do we have here? So one thing that we have is this idea of differential technological development. So this is the idea of developing things like a universal flu vaccine before we do gain-of-function research and increase the virility or case fatality of different diseases, so that we have better defenses for if these things were to leak out. Additionally, you can do things like regulation, so upping the safety levels within biosafety labs, or changing the regulations somewhat so that you can decrease those, the amount of leakage. Or you could think of interventions that target more malicious actors, doing better screening in airports, doing better screening of things imported through ports. There's a whole host of interventions that we could be looking at here, and which people are looking at in governments around the world to try and reduce the chances of these risks. So hopefully I've illustrated to you in this section of the talk that the potential for engineered pandemics is very real over the coming few decades. And this is something that we should be thinking about. And in my view, something that governments are not taking seriously enough and that needs more work. And this is an example of the type of existential risk that I think could, in a very extreme case, lead to a serious curtailing of the potential for humanity's long-term future. So I want to now move on to another type of existential risk. This is the risk from artificial intelligence. So I'm going to give you a little bit of background first. The development of artificial intelligence has been increasing rapidly. You've probably seen things like Siri on your phone, able to understand you much better, even just over the course of the time that you've had an iPhone. Similarly, if we look at chess computers, we can see historically the ability of chess computers rising rapidly compared to the ability of humans. And while this may look like it's taken a long time, what I think is particularly interesting is when you look at it from an individual's perspective. Say someone like Garry Kasparov. Up until 2000, he felt as though he could easily beat almost any computer at chess. And it just took a few years for him to be unable to beat any computer, any of the best chess-playing computers in the world at chess. And so you see these sort of rapid shifts from subhuman ability to above human ability in terms of how it's perceived by humans. And so we've got this trend of ever-increasing abilities for artificial intelligence. And you've got to ask, sort of, where will this stop? Is there going to be some sort of upper level that computers are unable to reach beyond in terms of intelligence? Or are we going to one day be able to have machines that have human levels of intelligence? Now, if you poll a group of sort of 100 of the most cited experts in artificial intelligence on their estimated arrival dates for human level intelligence, you find that what I found to be some pretty surprising numbers. So this is the top 100 most cited AI research. This is a number of different studies basically asking all the same question, which is asking people to give their estimated dates for human level intelligence at a sort of 10% probability, 50% probability, and 90% probability that you would have human level AI by then. And I found these numbers kind of surprising that in my lifetime, the best experts on this issue think that you could have artificial intelligence that is able to compete with humans on pretty much any domain in terms of cognitive capabilities. Now, this could have incredible upsides. If you were to have smarter than human level intelligence tackling issues like poverty or old age, climate change, or macroeconomic policy, these are sort of very data-intensive fields that humanity hasn't quite figured out how to deal with yet. Perhaps in part because we haven't been smart enough about it. So you could imagine it's very plausible that we could do a much better job of solving potential problems like this. But you can also imagine a number of downsides. And so this is really what a number of people in the AI community have started to be worried about. And this is known as the control problem. So to give you an analogy here, humans have not come to be the dominant species on Earth because we're faster than other species. We didn't beat gorillas to building huge skyscrapers and traveling across the world because we're the strongest species on Earth. We did that because we're the smartest. And the question that remains as humans start to, as computers, if they end up exceeding human levels of intelligence, is will we be able to keep them under meaningful levels of human control. Now, this is a sort of huge field, and quite exactly what I mean by meaningful human control is something that we could go into in a fair bit of depth on the panel later if people are interested. But needless to say, a whole bunch of people are very worried about the fact that we do not yet know how to program human values into a computer, and even how to ensure that once it is smarter than human level, once we ask it to go off and do things, it doesn't end up misunderstanding commands and going off and doing the wrong thing and potentially bringing out very negative consequences for humanity. In worst case scenario, self-replicating and self-improving, sorry, not self-replicating, simply self-improving to the point where it's optimizing for a wrong goal that could potentially wipe out all of humanity. Now, this is sort of an extreme case, but it's one that a lot of the top AI experts are thinking about. So this is Professor Stuart Russell, who is sort of seen as a superstar in the field of AI. He wrote Artificial Intelligence, A Modern Approach, which is the basic textbooks that is used by everyone across the world to learn AI. And he says the combination of value misalignment and increasingly capable decision-making systems can lead to problems, perhaps even species-ending problems if the machines are more capable than humans. So this is a guy who's clearly very worried about this. Elon Musk, you may have heard, sort of making similar pronouncements about this. Even Bill Gates has chimed in. I agree with Elon Musk and some others on this and don't understand why some people are not concerned about this. Indeed, in a similar survey, another question was asking people, assume for the purpose of this question that human-level AI will at some point exist. How positive or negative would the overall impact on humanity be in the long run? Please indicate a probability for each option. And so each person is giving their probabilities of how likely they think these outcomes are. Now, the good news is that most people think that, on balance, this is going to be a really positive thing for humanity, that we'll have far better outcomes than we currently have. The downside, sorry, it's dropped off the bottom here, but this one that I've pulled out here is an extremely bad outcome, open brackets, existential catastrophe. That was sort of how it was labeled on this survey. And what you find is that experts gave, on average, 8% credence to the fact that you have one of these extremely bad, potentially existential outcomes from developing human-level AI. Now, you might think, oh, 8%, that doesn't sound like a lot. But I don't think 8% is the sort of thing we should be willing to bet the future of humanity on. And so this is why I think that this is an issue that deserves far more attention than it's currently gaining. And I've been pleased to see this gathering more and more resources and more attention over the past year or so. Now, I want to take this opportunity to address a couple common misconceptions. I haven't gone into the arguments in a lot of detail about why I think that AI is potentially an existential catastrophe. But I do want to address some common misconceptions here. The first, I'm not arguing that AI is going to come soon. I'm agnostic on this question. I don't know if it's going to be in the next few decades, later this century, or even far in the future. All I'm saying here is that there's some risk that at some point it will be developed, and that we need to be preparing for that risk. And then pointing to some evidence that a bunch of AI researchers think that it's plausible that it might come soon, which is why I think it's urgent that we act on this issue now. I'm by no means saying that that's a likely outcome. Secondly, this argument that I've made has nothing to do with AIs being conscious or not being conscious. Whether they have some sort of consciousness is out of the question. The question is more, will they end up optimizing for the wrong things? Thirdly, what I'm worried is not about some sort of Terminator scenario where the AI becomes evil and sort of turns on humans and decides that it doesn't like us after all. What I'm talking about here is simply where we fail to sufficiently explain to an AI what it is that we're trying to have it do, and it ends up acting on instructions that it has misunderstood, or more accurately, that we have given poorly. So I want to reiterate here that this could be an incredibly positive and transformative technology. This century could be incredible if the sorts of numbers from the AI researchers are to be believed. And I'm really not convinced that they should be. And that in the long run, what's at stake here is actually pretty enormous. What we're talking about here in the existential risk category is ultimately the future of our civilization and potentially the future of the entire universe. So you may be asking, sort of, what can I do about this? This sounds like this could be a pretty big deal. What should I be doing about this fact? So I'd encourage you to start by reading Nick Bostrom's Superintelligence. This is a book that came out in 2014. It's since become an international bestseller. And this is really one of the key texts, or I'd say the key text, that has brought this issue to sort of global public consciousness. If Nick Bostrom's book is a bit long and a bit dense, which it is both, then I definitely recommend Stuart Armstrong's book, Smarter Than Us, which is only 60 pages and presents these arguments in a much more easier to digest format. So I'd start by having a look at these. If you're interested in this in the existential risk question more broadly, I'd involve you to get involved in movement building. Ultimately, these threats are not going to be coming online. Hopefully we have a few decades of grace. And this is the sort of time when we can start to build together a movement to work on these things. I think Kerry will talk about that more in his talk later on today. I'd also encourage you to go and work for an EA org working on these issues. And so I'm going to have a slight plug here. FHI is hiring. We recently got about $4 million in grants to work on a whole bunch of these issues. So if you know someone who has experience in emerging technological governance, who might want to help us map the space of AI policy potentials and also make a case for why regulation probably shouldn't be happening in the immediate term, please do send people my way. We're looking for someone with expertise in emerging technology governance to help us out with this sort of stuff. We have a macro strategy program. This is looking at, can we design heuristics to help reduce these risks and to improve the long-run future of humanity? For this, we're looking for historians of science and technology, futurologists, tech entrepreneurs, economists. We're not entirely sure who we want for this, but people who are happy looking into the future and using evidence to sort of extrapolate out and say interesting things about the future trends of technology and how we can improve those. Please do send them my way. We're looking for people with expertise in machine learning, deep learning, reinforcement learning, to help us refine these arguments on AI safety and start to try and find solutions, ways to basically communicate to these AIs better about what it is that we want them to do. Because that's a huge unsolved problem in this area, especially because this field is moving so fast, and the sorts of things that you are communicating with are changing very rapidly. Finally, if you're sort of younger in your career and haven't had a chance to get deep expertise in one of these areas, I'm going to encourage you to try out an internship with the Global Priorities Project. This is a project that I founded last year, working on some of these global prioritization and looking at policies that can help reduce existential risk. They've currently got a big program advising the Finnish government on what they can do to help put policies in place to reduce existential risk there. This is like a great place to start out if you're sort of earlier on in your career and want to take a step into this. You can check out their website at prioritization.org. So, in summary, the future could be very big. What we're talking about here when we're talking about existential risk is the potential curtailment of an enormous future for humanity. And how we deal with these emerging technological risks over the coming decade could have a really significant impact on humanity's long term. I'm not saying that they definitely will, but this looks like a potential place where we could intervene and greatly improve things. Finally, that the risks from engineered pandemics and AI appear to be both important and neglected. And I think this is a pretty good place to start working on these issues and reducing these risks so that we can ultimately have as good and prosperous a future as we possibly can. Thank you very much.